Have you ever wondered what a diamagnetic substance is? Or perhaps how it works? Well, prepare to delve into the fascinating world of physics and uncover the secrets of diamagnetic substances. A diamagnetic substance, quite simply, is a substance that does not have any unpaired electrons. This means that when it's placed in a magnetic field, it sets up a magnetic field in opposition to that field. Think of it as the introverted individual at a party, always trying to maintain a balanced, calm atmosphere around it. Let's take a closer look at diamagnetism. Diamagnetism is a quantum mechanical phenomenon where a material creates a magnetic field in response to an external magnetic field. The created field opposes the external field, causing a repelling effect. This property is inherent in all materials to some degree, but in diamagnetic substances, it becomes the dominant behavior. The term diamagnetism was coined by Michael Faraday in September 1845 when he discovered that all materials display some form of magnetic behavior. He conducted a series of experiments with different substances and found that certain materials like bismuth and antimony showed a weak repulsion from a magnetic field. This discovery was further developed by scientists like Lenz, who we'll talk about in the next scene, and Paul Langevin, who established the Langevin's theory of diamagnetism in the early 20th century. Diamagnetism is a fascinating aspect of physics that continues to intrigue scientists. The understanding of how and why certain substances oppose magnetic fields can lead to significant advancements in technology and our everyday lives. Stay tuned as we delve deeper into the laws that govern this intriguing phenomenon. Scene script. But how does this happen? It's due to something called the Lenz's law. This law states that an induced electromagnetic field will always work to oppose the change in magnetic field that induced it. So, when a diamagnetic substance faces a magnetic field, it induces a magnetic field in the opposite direction to counteract it. What's more, this induced magnetic field is very weak, weaker than the original magnetic field. Hence, diamagnetic substances do not get attracted to magnets. Instead, they get slightly repelled. It's like they're saying, "No, thank you, I'd rather stay where I am." You might be wondering, where do we encounter diamagnetism in our daily lives? Well, it's more prevalent than you might think. Diamagnetism plays a crucial role in various technologies and everyday appliances. For instance, the hard drives in our computers rely on the principles of diamagnetism to read and write data. The magnetic field produced by the reading head of the hard drive is opposed by the diamagnetic material on the disk, allowing the device to distinguish between the binary 0 and 1. Moreover, the understanding of diamagnetism is vital for engineers and scientists. For example, in the field of quantum computing, understanding diamagnetism is key to the operation of superconducting qubits, the building blocks of quantum computers. And let's not forget about magnetic levitation. This amazing phenomenon, which allows objects to float in midair, is made possible by diamagnetism. Some high-speed trains use this technology to reduce friction and increase speed. So diamagnetism is not just a concept in physics textbooks, it's all around us. It's in the technology we use, the transport we take, and even in the water we drink. It's truly fascinating how this subtle force shapes our world. A good example of a diamagnetic substance is water. Yes, the water you drink and bathe in every day is a diamagnetic substance. It's because water molecules do not have any unpaired electrons, and thus they oppose any external magnetic field. The world of diamagnetic substances is not just limited to water. Other everyday examples include copper, silver, gold, and even living organisms like you and me. Yes, human beings are also diamagnetic, albeit weakly. Voiceover. As we delve deeper into the world of diamagnetism, it's important to address some common misconceptions that often cloud our understanding of this fascinating phenomenon. First, many believe diamagnetism is a rare occurrence. This is not true. In reality, all materials display some form of diamagnetism, though it may be very weak and overshadowed by other magnetic properties. Second, there's a myth that diamagnetic materials can be transformed into magnets. This is incorrect. Diamagnetic substances do not retain a magnetic field once the external field is removed, unlike ferromagnetic materials. Third, there's a misconception that diamagnetic substances are attracted to magnetic fields. In fact, they're repelled by them, albeit weakly. This is due to their induced magnetic field, which always opposes the direction of the applied field. These misconceptions often arise from oversimplified or misunderstood explanations. A thorough understanding of the fundamentals, as we've discussed in previous scenes, can help dispel these myths and deepen our appreciation for the subtle interplay of forces in the world of diamagnetism. Next time you hear a myth about diamagnetism, you'll know better. Because understanding the truth about diamagnetism can help us appreciate this fascinating phenomenon even more. To summarize, a diamagnetic substance is one that has no unpaired electrons and opposes any external magnetic field. It does this by inducing a magnetic field in the opposite direction, as per Lenz's law. This induced field is weaker than the original field, causing the substance to be slightly repelled by magnets. And there you have it, the mystery of diamagnetic substances explained. Next time you're enjoying a glass of water or admiring a gold ornament, remember, you're interacting with a diamagnetic substance that's silently, subtly opposing an unseen force. The world of physics, indeed, is full of wonders.